Yo, what's up guys? Welcome back to another Josh Academy video. Today, we're going to be learning a question that you guys requested in the last video. But before we get into the question, make sure you hit that like button, hit the subscribe button, and hit that notification bell to become part of the notification gang. Let's look at this question, why don't we? If the growth of the population is modeled by the function p equals 500 divided by 1 plus 4e to the exponent of negative 0.02 t, where p is the population and t is the time in years, how long will it take the population to stop increasing in size? One important thing to note about this question is that it is a logistic growth question, thus making this a logistic growth function. So, something to know about a logistic growth, why don't we learn more about it? A logistic growth function has this S-shaped curve. Logistic growth functions have horizontal asymptotes at 0 and its maximum carrying capacity. We use logistic growth functions to model real-life situations where the population increases and then steadily stops. As you know, population doesn't keep increasing forever and ever. Where in real life do you see that? There is a limit to how much a population can grow. So that's where logistic growth functions come into play. We can model logistic growth functions in this formula. P of t is equal to k over 1 plus a e to the exponent of negative kt, where k is your maximum carrying capacity. This meaning that this is the maximum amount of things that this environment can hold. T is your time in years. Your P of T is where your population is. To find A, all you need to do is your maximum carrying capacity minus your initial population divided by your initial population. Now, let's look at this formula and use it in terms of the function that was given to us in our question. P of t is equal to 500 divided by 1 plus 4e to the exponent of negative 0.02 times t. Also important to note that negative k is your rate. So 500 here is our maximum capacity. 4 is our A. So in order to find A, first we need to find out what our initial population is. And in order to find the initial population, we would need to find what the population is when we started out. So if we started out, which means our years, or t in time of years, would be 0. Because that's when the time of years started. So let us try plugging 0 into our function. P is equal to 500, 1 plus 4e to the exponent of negative 0.02 times 0. Now let's simplify this further. Negative 0.2 times 0 can be simplified to 0. So now we have P equals 500 divided by 1 plus 4e to the exponent of 0. Now, let's plug this into our calculators and see what our answer is. It's important to note that e is just like pi, a rational number. Its value is approximately 2.718. There's still more to that, but it's just important to note that. And now, let's just plug into our calculator. And now, we know that e to the exponent of 0, using the zero exponent law, that means anything to the exponent of 0 is equal to 1. So 4 to the exponent of 1 is equal to 4. So this is our simplified function. Now let's simplify it even more. 500 divided by 1 plus 4 is 1 plus 4 you can make into 5. And now 500 divided by 5. And then now you can simplify it even more to get 100. And that is our initial population. Now we can go back and figure out how to find A, which is 4. So we know that our maximum capacity is equal to 500. And then you minus your initial population, which we now know is 100. Then you might divide that by your initial population again, which is 100. And if you do that, you will equal to 4. So logistic functions always have their horizontal asymptotes at 0 and their maximum carrying capacity. So in terms of our function, we know that our horizontal asymptotes are 0 and 500. As you can see here, our y equals 0 and y equals 500. At these points are where our graph asymptotes. So let's sketch this and model our function. Let's start with the asymptotes. As you can see here, I've already drawn out one of the horizontal asymptotes, which is y equals 0. Let us draw the other horizontal asymptote, y equals 500. Remember, this is just a sketch to show the model of our function. It doesn't have to be perfect, after all, it's just a sketch. Now we know if t equals 0, then our p has to be equal to 100. Let us draw out a t-chart just to organize our data and our points. So let's draw out our t-chart with the x and y values. The t will be the x values, the p will be the y values. Let us write out our data that we have, 0 and 100. So now, let's try finding another x and y value. Let's try -2. Let's plug -2 into our function. P equals 500 divided by 1 plus 4e to the exponent of -0.02 times -2. Let us simplify this even further. We can have p equals 500 divided by 1 plus 4e to the exponent of 0.4. Now if we simplify this even further, we will know that p is equal to 71.76. Now let's try another value. Let's try x is equal to 2. So p is equal to 500 divided by 1 plus 4e to the exponent of -0.2 times 2. Now let us simplify this even further. We will get p equals 500 divided by 1 plus 4e to the exponent of -0.4. Now let us simplify it even further by calculating it. Now plug this into your calculator and see what you get. Make sure you use the e on your calculator. If you calculate it, it should come out to 135.822. So let's put that down into our chart. Since we can't have a half a person or a quarter of a person, we must round to the nearest number we have, nearest whole number. So for the 71.76, let's round that to 72. And for 135.822, let's round that to 136. So let us plot our points. It doesn't have to be accurate, just sketch it, estimate it. 0 and 100, we know that it'll have its x on 0 and y will be 100. Estimate where that should be around. Same for the other ones. -2, 71.76. They should be pretty close to each other. And once you got those points together, make sure you make lines connecting them. Now, a logistic growth function, its graph moves from left to right. It starts at its horizontal asymptote, which is y equals 0. Then it moves up into an S curve. And that's how it should look like. It will look like it will touch, but it will never touch its maximum carrying capacity, which is horizontal asymptote, which is y equals 500. Now keep in mind, I know it says 135 on your chart, but it should be 136. I'm sorry, I wrote it down wrong into the chart, but it's all fine. Remember, it's 136. Just keep that as a note. So now, let us find the time in years that our population stops increasing in size. In order to do this, all we have to do is plug in different t's into our function until the population stops increasing. So now let's try and have 35 bt. Why not? Let's put 35 into where t should be into our function. If you simplify what we have on the left side first, we will have p equals 500 divided by 1 plus 4e to the exponent of -7. So if you plug that into your calculator, you should get an answer that is equal to 498.18. As you can see, our population is close to its maximum carrying capacity. It is not yet at 500, which means we can still increase the population a little bit more. Just like before, 498.18 is a decimal number, and we can't have a decimal of a person, a quarter of a person, so we have to round to the nearest whole number. In this situation, it's 498. So let's try another t. Let's see, maybe just a little bit higher. See if we can get the right amount of population. Let's try 38. Why not? Plug it into your function, and if you plug it into your function, it should look a little bit something like this. P equals to 500 divided by 1 plus 4e to the exponent of -0.02 times 38. And if you simplify that even more, it should become P equals 500 divided by 1 plus 4e to the exponent of -7.6. So if you plug that into your calculator, you should get an answer that's equal to P equals 499.001. So as always, let's round to the nearest whole number. In this situation, the nearest whole number is 499. Because we know that our graph will never touch 500 as it asymptotes towards it, we can stop at 499. So therefore, it will take around 38 years for the population to stop increasing in size. Anything that we calculate above 38 years, like 39, 40, 41, and etc., will only give us decimals. such as 499.999999, and we can't round up to 500. We can't have a quarter of a person either, or a half of a person either. So it's best to just round to the number below the carrying capacity, which is 499. And 38 gives us that. That's why we stop at 38. I hope that helped clear things up a little bit for you guys. This is the first time I've ever seen a question like this, and it's pretty interesting. I had to do a lot of research, but yeah, I've never done this in class before, but it's good to learn something new, I guess. Logistic functions. Okay, see you guys next time. Make sure you hit the subscribe button, hit that like button, and hit the notification gang.
What?
Peace out, guys. See you in the next video.